Okay, so Mail had a question, Anouk had the same question um, about this one, right? And then Mail also had a question about this one. So they're actually going to be, I'm going to show how to do this one, and it's particularly using GDC. So this is primarily use GDC. And this is amazing. You can prove it using this idea with the GDC. But Tin, I've also put up, Tin made a proof of this, and it's a very nice proof. Like you can think of it, how to do the sum of this one. I'll just post it, but the idea is U2, U3. He does all this, right? Is equal to n squared minus 10. And he uses what would be, it's n1 or n plus 1. I think that's something that he uses. And anyway, think about it. If you want to take a peek at Tin's, he has a very nice actual proof. You wouldn't be asked to show that proof like this, I don't think. But he does it's done very nicely. But if you want to see at the same time, two birds with one stone, to be able to do with GDC, it's wonderful. So let's just take a look at this. You can actually calculate, because this one's rather long to do. And they don't say, do you use GDC for this or no GDC? My guess is because of the length of this one, this would be a paper 2 question. So GDC paper 2. And those two would be connected. So how can you do this? Well, it's actually using your graphing calculator. And I'll show you how to do sequences and series at the same time. So this would work with a TI-84 or TI-84 Plus. What you're going to want is this stats. So what we can do here is, first, I'm going to change it around. And I'm going to find right away here, we can do easily the first two terms. So which would be 5 times 1 plus 8 plus 5 times 2 plus 8. And if I take the difference of these two, so this will give me 13 plus, and this would go on, dot, dot, dot. This one would give me 18. If I take the difference between these two, I'm going to have D. So that's going to give me 18 minus 13. So, oops. And that would give me D equal 5. We already know what my U1 is, and that's 13 at the same time. Therefore, I can use this sequence. UN equals our first term plus our distance, 5. And then it would be n minus 1, right? So that's our general formula for a sequence, that particular sequence. The series is just adding them. Okay, how can I use my calculator now? Well, this is how I put in the sequence. So just to test, second shift, I go over to ops, and there's sequence number 5. So notice what I have now. They're saying put in the expression. And the expression I want to put in is this one right here. The UN equals, so my arithmetic sequence, 13 plus 5, n minus 1. So I'm going to put that in. So I'm going to say 13 plus 5 times, now I can't use n, so I need to use x. So I'm going to say x minus 1. Done. Variable, what's the variable? It's x. I just press x. Start, well, it's going to be 1. And how much is it going up to? You can see right there, 8. So we're going to put in 8. Enter. Step, I always put 1. And I can go paste. There it is. It's now in the calculator. And when I hit enter again, there's my sequence. Done. How do I do the sum of this? Oh, this is even nice. Even nicer. So stats, go over to math. There, number 5. Click on number 5. Now I'm going to put in the same sequence as before. I could probably go up Can I go up one more? Yeah, and I'm going to hit enter. Ah, look at that. I put in that same sequence, and I'm going to close the bracket because it's already open, and I'm going to click enter. Ah, there it is, 244. Now, I'm going to do a little switcheroo with this. So to get an idea that this, so we already know then that this sum using the GDC, so my answer to this is going to be equal to 244. We know that. We just calculated it fast. My guess this would be a paper 2 question. If you want to prove that, that would be more of a paper 1 question. But notice that they already put that, so we know it's a GDC. So, but you don't even have to really, right? So you can see this. But Tin's proof will show you that this works. But you can also see it using a GDC. But how can you show this is going to be true on the GDC? Okay. So notice what we have. I'm going to bring back the calculator. So the idea here is I have a list of 8 numbers here. So what I'm going to want is this. So notice what we're going to have. Oops. So what I'm going to have here is U8 should be equal to U8 minus the sum of 8 minus the sum of 7. So watch this. We already know that our answer, that's 1 and all the way up to 8. I should get 48 as my UN term, right? UN is equal to 48. U8, U sub 8. So this should be, just to make this clear, I should get this to be 48, right? And that shows the same thing here. That's what we're going to see. It's really neat. So what happens, so this is how you can do it on a calculator very quickly, just to prove yourself that this is true. So I'm going to go back and do the sum of this again. So I'm going to go step back, stat. I'm going to go over to sum again. And I'm going to take number 5. There's my sum. Now what I'm going to do is I'm going to go back up to right here, the sequence. I'm going to take that, click it in, close brackets. But this time I'm going to go subtract and I'm going to do sum again. Take the sum of list and I'm going to go over to math, 5. There it is. I'm going to go back up here to take this one, enter it. I'm going to scoot over on this and I'm going to put this to 7. Then I'm going to come back over here. I'm going to close the brackets. The answer should be 48. Boom. There it is. Which shows exactly what I was talking to Anouk about in class. How you could find it using a sequence. This is another way of doing it. So I found this one. We know what the sequence looks like. We know how to calculate the sum of it. Now you can see that it's true. So that's true. Then this one, what Sophia did, is also true. And the proof Tin made. And Tin did a very, very nice proof. I'm going to post both this video and his proof up on the portal page. So I recommend taking a look at those. Okay, hopefully that helped. And you get to see how to use the calculator for this one.